This should be our last video together, at least for the spring EOC review for 2024. Okay, so we're going to dive right into this newest one here. It is called 60 Geometry EOC Practice 62 to 81. And make sure that is written on the top of your scratch paper where you're going to do most of your work. I know I'm going through these very quickly and actually giving you the answers, but I've told you guys so many times, I talked about it all the time, it's not just about the right answers. I'm not that interested in just getting a list of right answers. Of course, I want you to do your best, and I want you to make a lot of right answers when it really counts, of course. But you need the practice working the problems out. You need the practice with that cognitive discipline in your brain, working the problem out, looking at what's there, analyzing, thinking about what's there, drawing pictures, playing with it, and figuring out that answer, coming up with the right deduction. So that's what you need the practice with, right? It's not so much just putting the answer down and moving on. That's what you're going to do on the real EOC. You're going to be finding those right answers. Anyway, talked enough. Let's dive right in. What is the converse of this statement? I did look this up since the video a couple times ago, which caught me out. What is the converse of this statement? If Bob does his homework, then George gets candy. We're just going to reverse the if-then statement, but not the whole thing, just the substance of it. So the answer would be if Bob gets candy, then, if George gets candy, then Bob does his homework. So we're going to go with A on that one, okay? Converse is just reversing the statements, basically. So in a triangle PQR, you have to draw this thing, Sean. You got to draw this thing. Zach, I see you. Pick up the pencil and draw this thing. Let's do this, all right? So PQR. Don't know what it looks like yet, but that's okay. PQ is 8. QR is 12 and RP is 13. Oh, I drew it really nicely. That immediately means that angles across from the shortest side is the smallest. So R is the smallest. R is the smallest. And it has to be less than P, the one across from the middle side. So this is the middle angle, P. And then the largest angle is Q. It's across from the largest side. So we're going to go with A on that one. Got to draw that to see it. What is the contrapositive of the statement? If I am tall, then I will bump my head. So with the contrapositive, look this up too, we switch the statements and then add nots in there. So if I do not bump my head, we should start off with, then I am not tall. So we're adding double negatives in there. We're going to go with B on that one. Number 65, the diagram below shows a part of a roof. The highest part of the roof is called the apex. So the apex is right up here. So this creates a series of similar triangles. So that little triangle is similar to this triangle, which is similar to the whole triangle. Okay, we got 3 little triangles in there, and they're all similar. So that means we can set up some proportions of corresponding sides. So how many feet above the base is the apex? This is what we're looking for, X right here, the apex of the roof, okay? So we know this bottom side is 5, 5, and 5, so we're going to call it 15. All right? And we're going to look at just a big part of geometry is just seeing what you need to see. So we're going to look at just the 4 by 5 triangle here. So 4 is the left side and 5 is the bottom side. So I'm going to say 4 is to X as 5 is to 15. Because it's right side is to right side as bottom is to bottom of the whole triangle. So 5 is to 15. So it's just going to be, 3 times. So X would be 12. You can cross multiply and do your division if you want to, but it's just 3 times. So we're going to go with C on this one. Again, don't just watch the video. The videos, I'm doing about 1 minute per problem, but I'm the teacher and I mostly know what's going on, right? So you take your time. You think about it, process. That's how we create those quicker cognitive pathways, right? By practicing. Okay, in the diagram below, these two figures are similar. That means while the angles might be equal, the parts are proportional. So, including the perimeter. So, if AB and EF is in a 3-to-2 ratio, doesn't matter what all the other sides are. If they're in a 3-to-2 ratio, and the perimeter of this one is 12, then the entire perimeter's in a 3:2 ratio, and we can just cross multiply. 3x would equal 24, x would be 8. But what does it ask for? It asks for the perimeter of E, F, G, H. So that would be, oh, that is 8. X is what we solved for. X is the perimeter that we solved for. So we're going to go with D on that one. Notice how I double check myself on every one. In the figure below, K and M are parallel, which means that this creates a transversal situation. And remember, in a parallel lines and transversal situation, there's all these angles. There's 4 angles here and 4 angles here. There's only 2 types of relationships those angles have with each other. They're either congruent or they're supplementary. Okay, that's it. That's the only 2 types of relationships in this. And you see these types of transversals with things a lot. So what is the value of y? So we're solving for y. Now, alternate exteriors are congruent. So that and that are equal. Unfortunately, we can't solve for that because we have 2 variables. If there's x and y in there, we got to have something for the variable. So we need to figure out what the relationship then is between this and this. And the relationship between consecutive exterior angles, consecutive means the same side of the transversal, exterior means outside of the parallels. Consecutive exteriors are supplementary, which means they add up to 180. So we're going to add these things together as quickly as possible, right? While constantly double checking for careless mistakes. We got 8x plus 60 equals 180, 8x equals 120. X would be, let's divide that out. Oh no, my calculators are gone. Here's one. 120 divided by 8. I should be able to do that in my head, but got a lot going on right now. 15. And so x is 15, so we can plug a 15 in right here. So that gives us 45. 45 plus that means this angle is 65 degrees. 65 degrees. And these 2 angles form a line, or they're a linear pair, so that means they're supplementary. They add up to 180. So I'm just going to subtract that from 180, and I'm going to get y is 115. So let's go with C, 115 on that one. There we go. That one took a few extra minutes. Now, from what I understand, you're not going to be having proofs on the EOC this year, but we will look at this anyway because it's going to reinforce some of the things that we know to be true. And it's going to reinforce, so which of these is the most logical order for the statements and the reasons? We'll move through this very quickly. So the givens are always first, right? So 3 is going to be first. So we've automatically got it narrowed down to either B or C because they both start with the given, 3. So we say that AD and EC are parallel, great. AD and EC are congruent, okay, excellent, that's given. And then do we know that vertical angles are congruent? We do, but do we need that yet? Corresponding parts of congruent triangles are congruent. If 2 parallel lines are cut. So what are we trying to prove? We're trying to prove that AB is congruent to BC. Well, that's going to be at the very end. So 4 is going to be at the end. So it's B. See, we didn't even have to work through really the logic of we just had to know the rules of a proof, not work through the logic of the proof, okay? All right, 69, a truck is at the top of a ramp as shown below. How high above the ground is the truck? The height above the ground would be given by that line right there. So I'm going to draw that line. Of course, it's the same as this, but I'm going to move it over here so that we have a nice little right triangle, right? You can do that. And we have this angle 26, and we have the hypotenuse, right? So we need opposite from the point of view of angle 26. It's opposite over hypotenuse. OH is so, katoa. So it corresponds to sine. So we're going to do sine of 26 equals opposite over hypotenuse. We're going to substitute our 4 in, of course. Cross multiply, and the 4 just ends up right here, multiplied by whatever weird decimal that is. We're going to pop that into our calculator, make sure that our answers are in. Again, be sure not to just do sine 26 times 4. If you do sine 26 times 4, you're going to get the sine of a 104-degree angle because 26 times 4 is 104, I think. You want to be careful with order of operation. So I'm going to do 4 times the sine of 26. That's a good way to do it. 1.75. There we go. So D. D, we're going to go with a little bit. All right, 11 more to go, students. If a cube with side length 6, let's see. Cube with side length 6 has its dimensions divided in half. It's a cube, right? What will be the volume of the new cube? So we're going to have its dimensions divided in half, which just means we're going to have a much cuter cube with a side length of 3. 3 times 3 times 3 will be the volume of that cube, which is 3 cubed, which is 27. So we're going to go with C on that one. All right, when viewed from above, the base of a water fountain has the shape of a hexagon composed of a square. That's important. We do know that this is a square, so we know that all 4 of these sides are congruent. And 2 congruent isosceles right triangles. So we know that these triangles are isosceles, which means they're 2 sides that looks congruent are. What is the perimeter of the water fountain, or what represents the perimeter? So if we know that this whole thing here is 40 feet, and we know that that portion of it is 10 feet, and then there's a portion right here that's 10 feet, we know that this is 20. So that's 20 and the top one's 20. So remember, what we're solving for is perimeter. We don't need the dotted lines. Those are not part of the perimeter of the hexagon. The perimeter of the hexagon is that top side and this bottom side, which we already know is 20 plus 20. And then this, and this, and this, and this, and all 4 of those are going to be equal. And this is, since this is 20, we don't need that, but we're going to use it to get this. So in a 45, 45, 90, which is what this is, we're going to divide by the square root of 20 to get here. So 20 divided by the square root of 20. Now we haven't, square root of 2. Now we haven't really talked about this a lot because it's that old algebra skill, but we can't leave that on the bottom, so we're going to multiply top and bottom by root 2. So our corner then ends up being 20 root 2 over 2, or 10 root 2. There's this side right here. But we have 4 of those. So we have a top and a bottom, that's 20 plus 20, which is 40. And we have 4 of these, which is 4 times that, which would give us 40 on the square root of 2. Let's see if that's one of our answers. Yes, we're going to go with D on that one. Now, if you use the calculator and you got decimals, that is fine. But you got to figure out which one of these gives you that same decimal, all right? It's fine if you use decimals, Pythagorean theorem or whatever, but you're going to have to figure out which one of these gives you decimals. It just takes an extra 15 seconds. You got to type those 4 in and make sure that D matches the decimal that you got, okay? All right, what is the area in square inches of the triangle below? So this triangle is, it tells you somewhere, wait a minute. Oh yeah, it doesn't tell you. It shows you that it is equilateral, 10, 10, and 10. So that means that this is 5, this is 5, and this is 5. That means that that and that are 60 for sure. That means that that and that are 30 for sure, because each one totals 180, all right? So we're talking about, I know y'all get confused sometimes with sides and angles. So let me make that clear. This bottom side is 5. This bottom side is 5, and that bottom short leg is 5. So we need the height, because area of a triangle is 1/2 base times height. So our base is 10, so we know that's true. 1/2 times 10 times height. We just need our height. So we need this side right here, that height, okay? So we're gonna multiply, in a 30, 60, 90, we can multiply the short leg by square root of 3. So the height then equals 5 square root of 3. So we're gonna plug our 5 square root of 3 right here. And 1/2 times 10 is 5, 5 times 5 is 25 on the square root of 3. Again, like the last problem, if you've used your calculator, use Pythagorean theorem or whatever, good for you. You figured out the right answer. It's just the answers don't match the answer that you got. You got to figure out which one does, okay? So figure out which one of those matches the decimal that you got. Don't assume you did it wrong. You didn't do it wrong. You did it differently. Now you got to match up the answer. All right, so triangles, these triangles are shown below. We're given that R and V are congruent, so that is congruent to that. We're given that this side is congruent to this side. What do we need? What additional condition is sufficient to prove that RS, this here, is equal to this side is equal to this side. So we really just need to prove that the triangles are congruent. We can prove the triangles are congruent by knowing that those are right angles. If those are right angles, the triangles are congruent by hypotenuse angle, okay? HA, hypotenuse angle. So if we know that if we know that VS and RU are perpendicular, remember that that is the symbol for perpendicular, okay? All right, seven more, and we're doing okay on time. Okay, use the proof to answer the question below. We're trying to decide why are the triangles congruent. So remember to label everything that you're given. That is congruent to that, okay? Great. I know I have the advantage of different colors here. That is congruent to itself because of reflexive property. And this is the midpoint, therefore that is congruent to that. So all three sides are congruent, in the top triangle are congruent to all three sides in the bottom. That sounds like side, side, side to me, right? Side, side, side are congruent, then the triangles are congruent. Here's another similar one, it's not too bad. So 2 and 3 are congruent. They tell you that. What they don't tell you that these lines are parallel. But just the fact that it told us that those are parallel proves that the lines are parallel. So we're going to prove that 1 and 4 are congruent to each other. Well, we can do that because we can say that if 2 and 1 are congruent to each other, and 3 and 4 are congruent to each other because they're vertical angles, then 2 and 3 are definitely congruent, 1 and 4 are definitely congruent to each other. And the reason is, why is 1 and 2 congruent and 3 and 4 congruent? Oh, vertical angles. That was easier than I expected. See, my brain ran toward the solution, but I wasn't actually reading the problem. So the reason that those are congruent is vertical angles. So that was actually a very easy problem, and you guys were freaking out. Okay, a right cylinder cone has a radius of 5 inches and a height of 8 inches. We have not gotten into cones yet this year, but we're going to look at our cone here. The surface area is the bottom, pi r squared. That's the circle on the bottom or top, depending on which way you have the cone. But what it's asking for is the lateral area, which is the sides, the side, not the bottom, not the whole surface area. So it's actually just this portion right here, pi r L. And L is the slant height. We haven't talked about slant height a lot, or it's been a few months. Slant height is this L right here. So we need to solve for that slant height right there. And we do that with the Pythagorean theorem. So L squared equals 8 squared plus 5 squared. So L squared, a square root of both sides. And then L would equal the square root of 89, 64 plus 25. So then H, I've already forgotten what the formula was, but I think it was 5 pi times L, so we end up going with D. Yeah, it was. It was radius times Pythagorean. Man, I got a lot on my mind, sorry. Radius times pi times that slant height. Okay, a new pipeline is being constructed to reroute its oil flow around the exterior. So we're going, instead of, this is the old pipeline that took the nasty, dirty oil here, right through the middle of a national wildlife preserve. Who planned that out? So we're building a new pipeline here, and it has a right angle, okay? Which should be a clue that we're going to use properties of right angles. Maybe Pythagorean, maybe something else. How many extra miles will the oil flow? We just need to figure out what the old flow was, X, and then subtract that from the new flow. We can see that it's 92 miles. It's 60 plus 32 miles. So we just need to figure out X, and we're just going to do that using Pythagorean theorem. Square root of 32 squared plus 60 squared. 68 was the old flow. How many miles the old flow went? So we're going to subtract that from our 92, and the answer would be 24. So the oil's flowing 24 miles further, but it's not going through the wildlife refuge, which seems logical to me. The point, negative 3, 2 lies on a circle whose equation is that, all right? So let me actually erase this, and we'll put it on the graph. So negative 3, negative 1 is its center. Negative 3, negative 1, and There we are. Negative 3, negative 1. There's our center of the circle. The point -3, 2 lies on the circle. That means on the actual circle itself, right? Not inside it, but on the circle itself. So -3, 2, 1, 2. Oh, there it is right there. -3, 2. So that's the center of the circle right there. So this circle looks like this. So the question is, what's the radius? Easy. If you've drawn it, it's very easy. Most of you, many of you, would, and this is not an accusation, but you know who you are. You would look at that and go, I don't know, it's an equation of a circle, forget it. But if you stop and do some thought, give it some thought, draw a little picture, you realize, oh, I don't even have to use, I was thinking we were gonna have to use distance formula to get from here to there, but it's just a vertical line. It's just 1, 2, 3 up. That gave us those points on purpose so that if you drew it, it'd be an easy problem to solve, okay? So we're gonna go with 3 on that one, A. All right, 2 more. In the figure below, we haven't talked about the relationship between sine and cosine a lot. We've talked a lot about sine, cosine, and tangent, but we didn't talk about the relationship between sine, cosine, and tangent. But it's pretty easy to figure out if you know your sine, cosine, and tangent and what the side's proportions are. So if the sine of that is, what is sine? Ask yourself. Sine is opposite over hypotenuse, right? Here's here's x. So if the sine of x is 5/13, 5 is the opposite, and 13 is the hypotenuse. That means, using Pythagorean theorem, we can easily solve for the third side, which is 12. Now we can easily identify the other questions here. Cosine would be 12/13. That checks out. Adjacent over hypotenuse. And then tangent would be 5 opposite over adjacent, 5/12. So I'm going to go with A on that one. I'm going to look at the other ones. Definitely not 12/5. 5/12, but definitely not 13/2. We're going to go with A on that one. Very good. Very good, Mr. Pierce. Very good, everybody else in the class. Lorianne and Eli and Sean and Haley and Brandy. I see y'all. You're doing a great job. Sorry if I left you out. Sandria, Maylee, all right. Levi, maybe I already said Levi. Okay. If triangle ABC, so why do we have 2 left? I thought it was 61 through 80. Well, apparently there's another one. If triangle ABC is rotated 180 degrees around the origin, what are the coordinates of A prime? So we're just moving this one. I always have to remind myself what the rule is, okay? I'm going to go something really similar, really close to the origin, like 2, 1, and I'm going to rotate it 180 degrees, and it's going to end up at -2, -1. So we're just making both coordinates negative. So if this is 5, 4, we're going to go with -5, -4. A. Remember, I don't remember the rules very often, but you can figure out the rules if you just understand what it's talking about. 180 degrees, everyone knows what that is, especially if you were a skateboarder. Okay. In the diagram below of right triangle ABC, altitude CD is drawn to hypotenuse AB. All right. AB. Okay, this is the hypotenuse. Okay, this, you may not remember this relationship. You can actually figure this out lots of different ways, including Pythagorean theorem. But if AD is 3 and DB is 12, I don't know. We could think about it different ways, but this is geometric mean. We just had a test on this. So X is actually the geometric mean of these 2 figures. So what is the length of CD? So we can go short leg is to long leg and then look at the right triangle, short leg is to long leg. But then that's the same thing as the geometric mean. So x squared equals 36, x would be 6, and there we go. And we are done, students. Very nice job. I see you all. You did a nice job. Take your time on these, think about them as you continue to do the other EOCs where there isn't a video to watch. All right, take care.